guys, I wanted to record this video to demonstrate how you will solve for the t-test statistic for chapter 12, which we're looking at t-test for dependent means. So I took some of the data from the extra credit assignment that you guys had the opportunity to do last week, which was basically, if you did it, you already know, but if you didn't, you were asked to complete a measure that measured how relaxed or tense you were. And then you were to do a 10-minute guided mindfulness meditation and then take the same measure again. And I was wanting to see if there were going to be differences before and after the meditation. So if you took the measure, then these were the options that you saw. So this data is from muscular relaxation. How relaxed were your muscles? And you had the choices of extremely relaxed, somewhat relaxed, neutral, somewhat tense, and extremely tense. And I had to code that information in order to be able to actually compute it and put it in the formula. So I did that as follows. A 1 represents extremely relaxed, a 2 represents somewhat relaxed, a 3 is neutral, 4 was somewhat tense, and 5 was extremely tense. So just by looking at this data, even before we calculate it, we can see there's differences. So this person was somewhat tense before the meditation, and then after it, they were extremely relaxed. So we do see there's differences here between the before and after, but in order to tell if the differences are significant, we actually have to calculate the t-test. So that's what we're going to do here. So if we look at the formula, we know we need something called the sum of d, which is the differences, and then the sum of d squared as well as n. So in order to find the sum of d, we have to calculate the difference between each score. So each of these pairs represents one person. So this is person A's before score and person A's after score. And so we're going to find the differences. So 4 minus 1 is 3. 4 minus 3 is 1. 3 minus 2 is 1. 4 minus 2 is 2. 4 minus 1 is 3. 4 minus 1 is 3. 3 minus 2 is 1. 3 minus 2 is 1. 2 minus 1 is 1. And 4 minus 3 is 1. So these are all differences. Now we need to add this column up. And if we were to do so, we should get 17. And this is our sum of d. So I'll put that over here. And for the d squared column, we need to square each of these differences. So 3 squared is 9. 1 squared is 1. 1. 2 squared is 4, 3 squared is 9, 3 squared is 9, and then 1 all the way down. Next, we need to sum up all of these differences squared. And if we were to add them all up, we should get 37. And I want to remind you guys to always double check your work, because as I was doing this, I actually made 2 or 3 mistakes the first few times I did it. So yeah. I'm not immune, even though I'm teaching this class, to silly calculation mistakes. So even though it's really simple math, it's still very easy to make a mistake. So for n, this is going to be our number of pairs that we have. And in this case, we have 10. So we have an n of 10. So that's all we need. Once we have all these values, we can go ahead and plug them into the formula. So let's do that. So we'll start off with t. In our numerator, we need the sum of d, which is 17, and we're going to divide by the square root of 10, n is 10, times the sum of d squared, which is this value, 37, minus the sum of d, this value squared. So we're going to square that 17. And then our denominator is n minus 1, so it's going to be 10 minus 1. Then the next step is to just carry on with this. So when we take 10 times 37, we get 370. And when we square 17, we get 289. And then of course 10 minus 1 is 9. So we'll keep going here. So 370 minus 289 should be 81 divided by 9. 81 divided by 9 is 9. And now we need to find the square root of 9, which is 3. So we end with, oh, sorry, that should not be there. See, easy to make mistakes. All right, so 17 divided by 3. So our final answer, when we take 17 divided by 3, it should be 5.66, and the 6's keep going. So you can keep it like that, or you can round 5.67. It doesn't really matter to me. So this is our final value, 5.66. So now we need to find our critical value, which I wanted to show you guys how to do. So you're going to go to the back of your book. If you have the 7th edition, then it's on page 357. Now, remember I told you that in order to find your degrees of freedom, you need to remember whether your research hypothesis was directional or one-tailed or non-directional two-tailed. In the other video, the research hypothesis that I created for this was one-tailed because I stated something like mindfulness meditation will increase muscular relaxation. So that's a one-tailed test. And our degrees of freedom is n minus 1. That's how we find our degrees of freedom, the n minus 1, which was 9. So with a one-tailed test, 9 degrees of freedom. For step 2, I selected 0.05 for level of risk. So following that, this 1.833, that's going to be our critical value. So our critical value is 1.833. So if we were to draw this on the normal curve, it would look something like this. Forgive me, I am not an artist. That is why I teach psychology. So there's our normal curve. And our critical value will probably be somewhere around here. So this is our critical value. And then our obtained value was 5.66. That's going to be like way out here. If we were to plot that on here, like way out here. Let's just say right here. This is our obtained value. And so you can see that it definitely exceeds the critical value. It definitely goes way out there in the tails. So we know then we're going to have to reject our null hypothesis. And that makes our research hypothesis the more attractive option. So here it's showing you that there's a really good chance that mindfulness meditation is what caused the students to increase their relaxation. So I'll explain more of that in the other video that I have, but I just wanted to go over this and to help you guys kind of figure out how to do the calculations for this. So please, if you have any questions, don't hesitate to reach out and ask. Thank you.